Again, welcome to Statistics class, DSRT 734 class. This lectures cover multiple regression. Now, what's the difference between simple linear regression and multiple regression? A simple regression means we have only one independent variable that determines the dependent variable, or the X determine Y. With multiple regression, we have at least two independent variables that determine the dependent variable. It can be more than 2, 3, 4, any amount, but it's more than one. So for example, we may have x1, x2, x3 determine the y. So let's start with it. So our main objective here is to use the technology to find the multiple regression equation. Now, why do we use technology? Because now, for example, if we have 3 variables, well, that would be a large it will take time to solve this problem manually. Again, we can do it, but it will take time because 3 variable means we are going to have 3 different slopes. So again, in this section, we're going to use technology. And also we're going to discuss the standard error of estimate and also the coefficient of determination. The concept of the standard error of estimate and coefficient of determination for multiple regression is the same as the simple regression also. Then we're going to use the multiple regression equation to predict Y values. Now, in many instances, a better prediction can be found for a dependent or response variable by using more than one independent variable. So for example, in our previous examples, in the previous lectures, we only compare the company advertising expenses with the company sales. So only one variable, total advertising expenses, and the dependent variable, the income generated or the total sales by the company, which is okay. But what about if we consider other factors? So for example, here we say the more accurate prediction for the company's sales discussed in the previous session might be made by considering the number of employees on the sales staff. So that will be our second variable, as well as the advertising expenses, which is our previous independent variable. So in this case, we are going to consider 2 independent variables to determine the company's revenue generated in any particular year, the number of employees we have as a sales staff, and also the advertising expenses. So this is the formula for multiple regression equation. Previously, we have the simple regression equation is the y caret equal to b plus mx. Now we have m1 s1, m2 s2, m3 s3, mk sk, which means we have k number of independent variables. Now this is what will make it very time consuming to generate a multiple regression equation manually, because we have to consider all the slopes for each independent variable. So again, here we say the S1, S2, S3 up to SK are the independent variables. So we have K amount of independent variables. And also, as usual, the B will be the y-intercept, and also the y caret will be our predicted dependent variable, or y will be the dependent variable also. So we can see the concept of our previous simple linear regression and multiple regression are the same. The difference is with the multiple, that's why it's called multiple regression. The independent variables are more than one, so it's multiple regression. Now, because the mathematics associated with this concept is complicated, technology is generally used to calculate multiple regression equation, always, because each independent variable have its own slope. It's a long process. So we have an example here. A researcher wants to determine how employee salaries at a certain company are related to the length of employee. So the length of employment. So that's one variable, the previous experience, second variable, and education. So now in this question, we want to find out if the variables length of employment, previous experience, and education can determine employee salary. So the researcher selects 8 employees from the company and obtain the data shown on the next slide. Use the Minitab to find the multiple regression equation that models the data. So this is our data set. We have employee A, B, C, D, E, F, G, and H. Each employee have their annual salary. And the third column will be the number of years they are employed. The next fourth column will be the experience. And the last column will be the education. So our independent variable is X1, which is employment, X2, experiences, S3, education. And all the 3 variables have the same unit, which is years. So these 3 variables, S1, S2, S3, employment years, experience years, education years, is going to determine the salary Y. So again, this is multiple regression. So our goal is to find the multiple regression equation using the Minitab. So with the Minitab here, we say we're going to enter the Y value in C1, which will be our dependent variable. Then X1, X2, S3 values in C2, C3, C4 respectively. And then we select regression menu, then regression from the start menu. Then we use the salary. In this case, it's the same as Minitab, is almost the same as SPSS. So in this case, we have to select our independent variable. So we use the salary. We select the salary as our dependent variable, which will be C1. Then we select, so we can see the Minitab menu here. So we can see S1, S2, S3, those are our, again, independent variables. Then we have the predictor constant, the coefficient, standard error, the t value, and also the p value. So the system will generate the multiple regression equation, which is given here to be y equal to 49764, which is our y-intercept, plus 364 times 1, x1 plus 228 s2, 267 s3. So 364 is the slope for S1 variable. Then 228 is the S2 slope. Then 267 is S3 variable slope. And we can see the system also generates our R square value for S, which is 94.4%, and the S value, etc. Now, predicting Y values, same as a simple linear regression. Now we have the equation here. So in order to predict a Y value, I have to know the X1, I have to know the S2, we have to know the S3. We plug S1, S2, S3 value, then we can predict again the Y. So here we say to predict Y values, we need to substitute the given value for each independent variable into the equation. Then we calculate the Y caret. So this is our equation. Let's say we are going to predict an employee who have 12 years of current employment, 5 years of experience, and 16 years of education. So 12 will be X1, 5 will be S2, and then 16 will be S3. So we plug in the values and we find out that we are going to predict a salary to be 59,544 after, again, we substitute. And also using SPSS is the same process. We have to, again, select, this is our data set. We enter all the values. Then before we do the regression analysis, we have to specify which values are our independent and which values is dependent. And normally the box will show up, then we have to select. Then we do, again, the regression. So that will be the conclusion of this lecture. So in this lectures, again, we use technology to find a multiple regression equation and also the standard error of estimate and coefficient of determination. Also, we use the multiple regression equation to predict the Y values. Now we can see, I didn't mention that, but from the output, we can see our R square is our coefficient of determination. So here the R square means we have 94.4% of the independent variables explain the dependent variable or can determine the Y value, which is again the salary. Then we can say almost 6% or less than 5 points is unexplained. It's the unexplained variation. So again, wish everybody the best. And in our next lectures, again, we are going to use the JSP in our course. Again, we are using the JSP for most of all the startup. And I'll be making lectures on that soon. Thank you.